Welcome, everyone, to this talk. Today, Dr. Ryan Milligan, who's a lecturer at the Astrophysics Research Center here at Queen's, will give us a talk about the solar eclipse. So Ryan currently holds the SFC Ernest Rutherford Fellowship. He did his PhD at Queen's. He was a postdoc at Queen's, NASA, and Glasgow. And his research over the past 15 years has focused on the sun, solar activity, and space weather. He's also a very avid eclipse chaser, and so hopefully during this talk he'll give you some of his experience chasing eclipses all around the world. I think he's done something like 10 so far. So Ryan, take it away.
Thank you, Ernst. Yeah, I've been researching for 15 years, not 50 years. I'm not that old yet. Thanks. So yeah, thank you all for attending this afternoon. I'm going to talk a little bit about the partial solar eclipse that we're going to be experiencing from here in Northern Ireland. Indeed, the rest of the UK and Ireland and parts of Europe as well will get to see it. And I'm going to talk a little bit about solar eclipses in general, a bit about some of my own experiences in chasing solar eclipses, most importantly how to view a partial solar eclipse safely, and I'll finish up with some talking about how to photograph an eclipse if people are so interested. And just on my title slide here, I'm showing a sequence of images that I took during an annular solar eclipse in Tanzania in 2016. You can see here the moon traversing the disk of the sun over the course of a few hours, and I thought this was pretty pertinent because the eclipse that's happening next week is in fact an annular eclipse. It's not a total solar eclipse, but it's an annular eclipse. These eclipses occur when the moon is a little bit further away in its orbit, and it appears a lot smaller than the solar disk, and so it can't block it out completely. Now, the path of annularity, as it's known, as opposed to the path of totality, actually only occurs in north. It's anywhere else in the northern hemisphere that gets to witness this, gets to see a partial solar eclipse. And so here in the UK and Ireland, we will see the partial solar eclipse. In Belfast, we'll see about a 30% coverage. So about a 30% of the solar disk will be covered up by the moon. And that will vary slightly according to location. So if you're, say, in Scotland or somewhere, you might get 32%. If you're in London or Dublin, it might be closer to like 25%. So it's not worth traveling anywhere outside your area. If you've got a clear view of the sky, then you can view this eclipse. It's going to start around 10 in the morning, about a few minutes past 10. We'll get first contact, and it'll last for about 2.5 hours until about 12:30. So it's finished up by lunchtime, and the peak of the partial phase will be around 11:15. So if you get a chance to go out and view it at all, around 11:15 is probably what your best bet if to go outside and view it. So that's the bare basics of the information. That's what's going to happen. But I'm going to talk now more generally about solar eclipses, and I'll go into a little bit more detail on what we're actually going to see from here in Belfast later on. So just as a kind of overview, my slide's going to change. Sorry, my iPad is just frozen here. Okay, so what is a solar eclipse? So a solar eclipse occurs when the moon passes in front of the sun. That's it in its basic form. But a total solar eclipse is when the moon completely obscures the sun in its entirety. So you have none of the visible photosphere visible from Earth, and that's when you get to see the solar corona, this spectacular, magnificent sight that I'll talk a little bit more about in a few minutes. And these happen because the moon is 400 times smaller than the sun, but it also happens to be 400 times closer. So they have the same apparent diameter in the sky, at least on average. And that on average is important because, like I say, the moon's orbit is not perfectly circular. Sometimes it's further away, sometimes it's a bit closer. And when it's further away, it appears smaller in the sky, and you're left with what's called an annular eclipse, are often called the ring of fire, because you have this ring of the solar photosphere that's still visible. And this can often only be just like a few percent of the solar disk that's still visible. But if you're out and about, you would have no knowledge that this is actually happening, because the sun, the brightness of that last few percent can still just make it appear like daytime. Whereas during a total solar eclipse, when 100% of the sun is obscured, day can turn to night. and you can see some of the stars and other planets if you're lucky, and you get all sort of shadow effects and all as well. But an annular eclipse is really just a type of partial solar eclipse. It just happens to be a nice, symmetrically well-behaved one. And we have this ratio of the sun appearing and the sun and the moon appearing at the same size in the sky, and there's no other planet in the solar system has this remarkable ratio. So we're very fortunate to be living on the only planet that has this ratio, and also at a time when this is accessible to us, because as we know from the Apollo missions that the moon is actually moving away in its orbit at the rate of a few inches per year, and so in a few 100,000 years or whatever, we're only going to be able to get annular eclipses. So we're living in an era now where we have we can see total solar eclipses. So I would urge you to take advantage of that if the opportunity ever comes up to witness one. It really is the most spectacular sight you're ever going to see in nature, and they occur. You see in the media sometimes they can say they're pretty rare, but they actually happen roughly on the order of every 18 months or so somewhere on the planet. But it often involves having to go out of your way to try and see one. So here is a map of the Earth showing all the total eclipse paths for a 40-year period from the mid-90s to about 2035, and you can see these bands, these paths of totality, and where they occur over the surface of the Earth. And these can be very, very narrow. This is the moon's shadow being projected onto the Earth as it obscures the sun, and these paths can often be only maybe 50 to 100 miles wide, and so you need to be within one of these paths during totality in order to be able to see the solar corona and the Baily's beads and the diamond ring and all the other effects that you associate with a total solar eclipse. But not to be confused with lunar eclipses, although, sorry, that's being, not to be confused with lunar eclipses, although solar eclipses and lunar eclipses often do occur in pairs. So last week there was a lunar eclipse that was visible from the southern hemisphere. Next week we get the solar eclipse, corresponding solar eclipse visible from the northern hemisphere. And the point I try to educate people on is the fact that a lunar eclipse occurs when the moon passes in the Earth's shadow, as viewed from the sun, and the sunlight then gets scattered through the Earth's atmosphere. All the blue light gets scattered out, and the moon turns this blood red color. It's often called a blood moon as well. But basically, if anywhere on the night side of the Earth where you have a view of the moon, you can see a lunar eclipse. There's no real travel or expeditions required to view a lunar eclipse. You can view it from anywhere on the night side of the Earth. The solar eclipse, on the other hand, happens when the moon passes between the Earth and the sun and casts a shadow back onto the Earth. And so here you can see the umbra of the moon's shadow here, pointing to this very localized area on the Earth. This is this shadow that I was talking about that can often only be 50 to 100 miles wide, and you need to be within that shadow in order to see the totality here, like you see on the right-hand side. This where you can see the solar corona. Anywhere outside of that umbral path, where if you're in the penumbra, then you get to see a partial solar eclipse, like we'll see here next week. But you don't have to be on the Earth to see the moon's shadow. If you happen to be on the International Space Station, you can often look down onto the Earth and see the moon's shadow being cast onto the planet. So I think this is an image taken from the ISS during the 2006 eclipse over Turkey. I think this might be the Russian eclipse. You can see the moon shadow. So basically, all the eclipse chasers are gathered within this shadow, looking back out at the solar system to see the magnificence of the solar corona. And this is a movie taken with the Discover spacecraft here, where you can see the moon shadow passing over the North continental United States in 2017 during probably one of the most watched solar eclipse events in recent times. And so what do you see if you happen to be lucky enough to be standing in the moon's shadow during the moment of a total solar eclipse? This is the kind of anatomy of a solar eclipse with all the different features. The most prominent thing you see is the solar corona. There's this pearly white, ethereal looking phenomenon stretching beyond the limb of the sun. This can only be seen during a total solar eclipse when the photospheric light of the solar disk is being obscured by the moon. You can see this ethereal outer atmosphere of the sun. You also see this thin, narrow band called the chromosphere, this red color, which actually gets its name from the color red as it was measured during eclipses. This is a very thin layer above the photosphere and below the corona. made sort of predominantly of hydrogen emission. You get Bailey's beads in the diamond rings, where the last chinks of photospheric light creak through the gaps between the lunar moons. And if you're fortunate enough, you might get to see a prominence, which are these clouds of hydrogen gas being suspended above the solar limb by magnetic fields. And for a long time, scientists in a few hundred years ago didn't actually know if these features belonged to the moon or belonged to the sun, because they could only see them when the two were lined up. But we know now that these are a solar feature. Sometimes they're associated with solar flares, coronal mass ejections, and other types of dynamic solar phenomenon. And what you see in the solar corona can often depend on what part of the solar cycle you get to see a solar eclipse during. So the sun has a natural cycle of activity where the number of sunspots rises and falls with a period of roughly every 11 years or so. It's called the solar activity cycle. So if you were to view a solar eclipse during solar minimum, when the sun's very quiet, you get these sort of equatorial helmet streamers that they're known. The sun's magnetic field is very relaxed and well behaved, compared to solar maximum, when there's lots of sunspots on the solar disk and there's an increased solar activity, the sun's magnetic field becomes more erratic and more twisted and disturbed. And you can see now that the solar magnetic field becomes much more distorted. And so the solar corona is going to look, no two solar eclipses are ever going to be the same. How they're viewed from Earth will depend very much on what phase of the solar cycle you're in. And right now, we just happen to be coming out of a deep solar minimum. So we've just come out of solar cycle 24. It was a rather weak solar cycle compared to some of the previous ones, and we had a very deep solar minimum here for the last few years. But sunspot numbers are starting to rise as we enter solar cycle 25. This is an image of the sun taken by the Solar Dynamics Observatory spacecraft, just taken this morning, showing a small sunspot group here in the northern hemisphere. These may be visible around the time of the solar eclipse, but this region itself, if I go back a slide, this region now will take about a week to traverse the solar disk towards the solar limb, and so this one will be gone by the time of the partial eclipse occurs here next Thursday. But there is a small sunspot group down here in the southeast quadrant which may develop and grow, and it should be around about disk center by this time next week if it survives. But again, we're still at the very early stages of the solar cycle, so the chances of there being sort of sunspots on the disk during the partial phase is quite low, actually. And so I talked briefly there about the solar eclipse of 2017 that was visible across the entire continental United States. As I showed in an earlier slide, these eclipse paths can often be over the oceans, they can be over the deserts, they can be over Antarctica. And so to have a solar eclipse traversing the entire continental United States, and it was the only country that got to see the 2017 eclipse, was quite a spectacle. It went from coast to coast on August the 21st. And it was estimated to be one of the most watched events in human history, an estimated 215 million people. And it gave us solar scientists, an opportunity to try and study the solar corona in a bit more detail, to answer some of the outstanding questions that we still have. For example, why the solar corona is 1,000 times hotter than the surface is still a big outstanding question in solar physics. We know it has something to do with the magnetic fields, but how that energy is transferred from the surface out towards the corona is still very much debated. And this region that we see in the lower corona during eclipses is where we think that solar storms get accelerated and energized, but we can't view this region of the sun's atmosphere very easily from space, but we can see it during a total solar eclipse. So this image on the right shows you the red image is taken with the LASCO spacecraft instrument on SOHO. The middle image is taken with the Solar Dynamics Observatory, but the inside bit, this black and white bit in the middle, was taken by the ground-based observers during the moment of totality. And it shows us now the complete picture from the solar surface out towards the solar atmosphere, and we can measure things like temperatures and densities and all sorts of parameters that help us understand the sun's behavior. And so, as Ernst mentioned at the start, I've been an avid eclipse chaser now since my PhD days at Queen's. I've traveled to see 10 solar eclipses so far, including the one in North America, Chile and Argentina, the Faroe Islands, Turkey, Tanzania, which was an annular eclipse, Siberia, China, Indonesia, and Australia. All the rest were totals. And this website, eclipse-chasers.com, allows you to record where you were, what sort of cloud conditions you had, what sort of coverage you had, and it calculates all your how much totality you've experienced throughout your life. And of course, there are many people who've seen dozens more eclipses than I have, but it becomes very infectious once you start to see one. You actually want to see them all as much as possible. And so I've tried to take some photographs during my eclipse trips to remember the occasion, and I've been pretty successful so far. These are some snapshots that I've taken for the first 9 eclipses. You can see I was clouded out in the Faroe Islands in 2015, unfortunately, but statistics aren't too bad. Again, here's my annular eclipse shot from Tanzania in 2016, and the most recent solar eclipse was actually in Chile in December. And so, following the guidelines of both the UK and the Chilean government, I decided to make a last-minute trip down to the Southern Hemisphere to try and witness this event for myself. Did all my PCR tests, COVID insurance, wore the mask for 15 hours on the flight, flew to Santiago, was confined to my hotel for a few days before allowed out down to Temuco, where I then drove to the town of Billarica, where they have this famous volcano. That was my intended eclipse viewing site. On the day, of course, it was cloudy, and I tried to drive around to find a patch of clear skies. And sadly, that was all I got to experience. So even going for a 2.5-minute eclipse and getting to see the last few moments of the partial phase was about all I managed to get. But it was still, I would have regretted not going more than I regretted going. So it was definitely a worthwhile trip. And so, going back to the partial eclipse next week, what are we likely to see from here in Belfast? Well, anybody who's been trying to conduct astronomy from Northern Ireland knows it's probably going to be cloudy and rainy, but you know, we've had some decent weather these past few days. It is June, we're coming into summer, so we can try to be a bit more optimistic. This is an animation that I've taken from the timeanddate.com website, which is very informative. It has a lot of information on there about all the eclipses coming up. This will be a movie that'll show roughly how it will appear from here in Belfast, and again, it'll differ slightly depending on where you are in the country. Here's the sun. You can see the silhouette of the moon coming in here in the top right corner. You get first contact then around 10 a.m., a few minutes past 10 in the morning. The moon's then going to pass in over the northern half of the sun until you reach a maximum coverage at about 11:15, 10 past 11 or so. And after that, then the moon's going to recede away off to the left and finally disappear. We get fourth contact about 25 minutes past 12 on next Thursday. So I'll let that movie run again. Hopefully, if it will. So there again, so the moon's coming in at the top right-hand corner, cutting out through the top half of the solar disk. So starting again about 10 a.m. up till about 11 minutes past 11, and then the moon begins to recede and disappear again by sort of lunchtime on Thursday. And this is a map showing pretty much the same thing. So you can see from this that where we are here, we get about a 30% occultation by the moon. And that increases sort of slightly again. If I said if you're up in northern Scotland, you might get sort of 35%. If you're down in southern England, you might get less, sort of 20-25%. Of Europe doesn't really get that much at all. So we're actually quite fortunate in our location this time. As you can see from the Time and Date website, that this day, the 10th of June, is cloudy 85% of the time over the last 20 odd years or something. But again, fingers crossed, you might get a gap in the clouds long enough to be able to view something. This is roughly what it'll look like based on a photograph I took from Nebraska in 2017 of the partial phase. You can see I've rotated it slightly to show you how the moon will appear in front of the sun around the time of maximum coverage. At this time, we did have a few sunspots, even though we were at the trailing end of solar cycle 24. We did have some sunspots visible there, so you never know your luck. There might be a few that have appeared by this time next week. Now, a few tips on safety. You're going to hear a lot about safety and how to view an eclipse safely in the news coming up in the next few days. And so you've probably seen this image or something similar in the news where this guy on the right ignored all the advice of the scientists and looked directly at that solar eclipse in 2017. Please, please, please do not look directly at it. You can do serious damage to your eyesight. And I'm going to show you some ways to observe it a lot more safely than what this guy did. So never look directly at the sun. That goes without saying. I'm going to repeat that quite a lot, but there are plenty of other ways to try and view it safely. The easiest way and the best way possible is to use approved solar eclipse glasses. Here's a pair that I have here. We have some in the department. If you can track some of us down, we might be able to get you for a few pairs. We're not sure how many we have. You can try looking online, try local astronomy groups. Astronomy Ireland seem to have some of available. Irish Astronomical Association might be also worth a try. Amazon had them for like £5 for 2 pairs. Other internet sites might have more. You could try using a telescope or binocular with approved filters. Again, if you're unsure or uncomfortable doing this or don't know how to do that, please don't. But you can buy what's called a black polymer solar filter. Here's a sheet that I have. I try to keep a few of these in my camera bag. They're 4 inches by 4 inches, and I wrap these around a filter for telescope and binocular as well. This is about £8 on Amazon as well. But again, demand for these things often increases before an event such as this. So this is why we've given this talk a week in advance of the event, so that people can make the necessary arrangements to source whatever equipment they need to view it safely. One of the simplest things to do is to just build a basic pinhole projector, and there's lots of instructions available online to show you how to do this. But essentially, you're taking 2 sheets of paper or a card, you puncture a hole in one of them, and you project an image of the sun onto the other piece of card, and you'll get to see the eclipsed sun on the background. Again, perfectly safe to do this, and a great way to get kids involved, or if you've young people in the house, you want to just project the image onto a wall or a piece of card. It's all pretty safe to do. Welding goggles are also an option, I've heard. This is a picture I took of a girl in China in 2009. If you have a family member who's a mechanic or a welder, if they have a set of welding goggles rated 14 or higher, they should be safe for viewing the eclipse through. Not that it's any relevance, but if you do ever get to see a total solar eclipse, you don't need any eye protection during totality. But if any fraction of the solar disk is visible, then you really need to make alternative arrangements to view it safely. Here, so and just to give you a bit of an example, here's a sequence of images that we took in Tanzania in 2016 during the annular phase, the partial phase of an annular eclipse, I should say, where we had found this small telescope at the lodge we were staying at, and we rigged it up to project the image through the telescope onto this piece of card here. So you can see, even at this phase of the eclipse, where about, say, I don't know, 95% of the solar disk is covered, it's broad daylight. You can see it's still daylight around us. You would have no idea that this was happening if you didn't have a facility like this rigged up. And just so happened at this time as well, there were some sunspots visible as well, so we got that made a nice kind of photo sequence as well. But again, beyond all that, there's a lot of just natural ways using household objects to try and view the eclipse. Just be imaginative, be creative. Again, get kids involved. If you have nieces and nephews or young children, is a great way for them to look for peculiar shadows that you can see coming through the gaps of the leaves and the trees. These act as little pinhole cameras and project the shadows just onto the ground or onto a wall. Here's someone using just a kitchen colander. You can see the little crescents through all the holes in the colander. Ritz crackers was also a great idea I heard once, where you have the tiny holes in the biscuits that appear as little crescents onto a piece of card or a table or whatever. Again, a picture I took in Tanzania of a chair beneath some trees. You could see all the little crescents. Or at the very, very least, you could just use your hands and just create little pinhole gaps between your fingers, and you would get to see the crescent shapes as the moon progresses in front of the sun. So there's myriad ways to try and view this, or at least experience it without having to resort to getting glasses or any sort of kind of expensive equipment, with just knowing where to look and how to look for it. So just think outside the box a little bit there as well. If you have any interest in trying to photograph it, then you will need a digital SLR. So I have a digital SLR here that I bought for a few £100s, and I only use really for eclipses and astrophotography. It's nothing really fancy. And you also need a tripod to keep it steady. And I have also my own purpose-built solar filter that I use for the partial phases of eclipse, taken just with a tube of Pringles and one of these black polymer filters. And so for less than a tenner, you can build your own solar filter. Doesn't have to be sour cream and onion, but pretty much has to be sour cream and onion. Anybody else eats other types of Pringles is just weird. But even if you take a photograph of the eclipsed sun without a filter, you'll notice that you can even start to see images in your photographs off the partially eclipsed disk as well, just due to the light being refracted off the different optics within inside the camera. So again, a different way to look out for the eclipse itself. And even try photographing the eclipse using other objects. So this was a sunset eclipse that we took in Argentina in 2019. Here's the moon blocking out the northern part of the sun, and it was just as it was setting behind some mountains. So you get this sort of dual eclipse phenomenon as well. So again, next week's one will be sort of late morning, midday. So it's probably going to be pretty high in the sky, but you could try looking at taking pictures through trees or behind buildings or whatever else. Just to save you the trouble, here's some pictures I tried taking with an iPhone, just using a set of standard eclipse glasses through the camera. The pictures come out rubbish. I don't think it's not worth trying to damage your expensive phone by subjecting it to direct sunlight like that. So I would advise against it. It's really not worth an effort. But again, look around you, look through the leaves and the trees on the ground for the shadows, and take pictures of them as well. And then another way to do it, again, probably more relevant to a total solar eclipse, is to do a time-lapse movie. And again, this is a movie I took in Argentina just using a simple GoPro camera for about £100. I set it up in the corner away from those mountains. We're a group of colleagues, and we could just sit back and enjoy the eclipse and not have to think about exposure times and pointing and all the rest of it. So I'd set it up in this corner, and this is about 1 hour's worth of the eclipse condensed down into 1 minute. So I'll let that movie run again. So we're probably in the partial phases right now. The moon's shadow is going to come in from left to right in this movie. You can see the skyline change as it gets to more dusky. Then we experience totality. There you can see the solar corona in the image, and the moon's shadow then disappears off to the right. So again, time lapse is another way to try and view this event as well. And so after next week, when is the next total solar eclipse? Well, it's actually at the end of this year on the 4th of December. And unfortunately, it's only visible from Antarctica. It's a pretty brief eclipse, given that it's occurring at the polar regions. It's 1 minute and 50 seconds at its maximum. So it's a long way to go for such a short eclipse. And Antarctica is generally hard to get to anyway, but there are companies offering guided tours. So if you have a spare £15,000 lying around, they'll happily take your money and ship you down to, well, actually they won't ship you down to Antarctica. That doesn't include flights. So you need to get yourself down to Terra del Fuego, and then they will take you on a 3-week cruise and to see the 1 minute 50 seconds of totality. So I may have to give that one a little miss, unfortunately. But after that, we're in good shape for the rest of the decade. So the next one after this is going to be in 2023. It's going to be a hybrid eclipse across Australia, Indonesia, and Papua New Guinea. Again, a hybrid is when it's an annular eclipse at part of its phase and total at another part of the phase. This is due to the orbit of the moon and sometimes to do with the curvature of the Earth as well. Our colleagues here at Queen's in the Astrophysics Research Centre are going to ship some experiments down to Indonesia for the total part of that eclipse in 2023. We have an annular eclipse then that same year, which is a kind of a lead into the big one, which is going to be in April 2024, when there will be a total solar eclipse visible across Mexico, the USA, and Canada. It actually cuts through New York State, so that would be a relatively easy one to get to for most people if you fancy a trip to the States. Then again, a couple annular eclipses in the southern hemisphere before the next big total one, which will be in Spain in 2026. So again, very easily accessible there if you want to start making plans to see a total solar eclipse. And then there's the list of the rest of them going on through the rest of the decade, right up to the day after my 55th birthday, when I hope I'm still around to see a total solar eclipse in South Africa and Australia. But saying that, the partial solar eclipse that we're going to see next week actually kicks off a run of partial solar eclipses that will be visible from somewhere in Ireland every year for the next decade, apart from 2023 and 2029. So we're actually in good shape for partial eclipses from here for the next decade or so. So if you do happen to locate a pair of eclipse glasses, hold on to them. You'll get plenty of use out of them over the next few years. And again, even going back to the total solar eclipse visible from Spain in 2026, we'll get a very strong partial here. So I think over 90% of the solar disk will be covered as viewed from Ireland during that one. But I would highly recommend you make the effort and travel to Spain and get yourself into the path of totality if at all possible. And just because I know someone might ask this, when is the next total solar eclipse visible from Belfast? Well, it's going to be on 14th of June, 2151. So in 130 years and 12 days, you have to wait if you want to capture a total solar eclipse from Belfast. And it'll probably be cloudy anyway. So don't wait 130 years. Try and find a total solar eclipse before then. And with that note, I'd like to leave you with a quote by Rebecca Jocelyn, an eclipse chaser from the early 20th centuries, who wrote that, "Now eclipses are elusive and provoking things visiting the same locality only once in centuries. Consequently, it will not do to sit down quietly at home and wait for one to come, but a person must be up and doing and on the chase." And that's why we do what we do and spend thousands of pounds traveling thousands of miles to witness these celestial events that last mere moments. But trust me, it is definitely worth it. So my email address, in case anyone has any questions that they remember later on, r.milligan@qub.ac.uk. I'm also on Twitter and Instagram at Ryan O'Milligan, where I'll be sort of tweeting photographs and updates closer to the time and during the event itself. But thank you very much for your attention. I hope this has been of some interest and use to you. We will hopefully open up the chat. Ernst can read out any questions that people might have, but I hope you get clear skies wherever you are, and please, please, please be safe when viewing the eclipse. Thank you for your attention.
All right, thanks, Ryan. So as Ryan said, if you have any questions, you can put them in the chat. There's already one question. Otherwise, if you raise your hand, I can probably unmute you and do that, but maybe the chat is easiest. I'll read them up. And there's already one question. Can you also make your own glasses using those black polymer sheets I'd buy for my camera?
Yes, it's essentially the same material. Yeah, as far as I know, the black polymer material. This comes from a company called Thousand Oaks. A very reputable company. You can I can post pictures of this online later as well. But it's essentially the same material. Yes, some of them, the sun, like the pictures I've showed during my talk, and the photographs I take, the sun will appear orange. Different companies make different types of a polymer, so some will appear white, some might appear yellow. So don't be too dissuaded by that as long as it's safe. During the 2017 eclipse, Amazon was flooded with cheap knockoff eclipse glasses, so just be careful to buy them from reputable dealers. I don't imagine that's the case in this instance. People were just trying to cash in on the eclipse of 2017 because it was such a big event. I'm hoping that's all died down by now. But yes, and if you do buy these, and if you do fit them over a telescope or a set of binoculars, make sure they go on the outside on the objective lens, not at the back, because then the light will just burn through the telescope, burn through the material, and burn through your eyes. So these go on the outside. Again, you just jerry something up like this, tubular snack can, and tape some filter around it. Pretty much does the same job, yes. And so, and these come in all sorts of sheets and size. I just buy the 4-inch by 4-inch. I think they come in 8-inch by 8-inch and bigger as well. But this was a couple of quid and a handy purchase to have, yes.
I was going to say, and to add to that, don't use your eclipse glass in front of your camera because they won't cover the entire lens. So yeah. Also be careful with that. So buy the larger sheet when you can. So does anyone have any other questions? Please put them in the chat or raise your hand and I can unmute you or... Don't see any questions yet. So let me ask you one then. So what was your favorite eclipse to go to so far?
Oh, I think the American one in 2017 was a bit special. I traveled to a lot of those eclipses by myself, and my friends thought I was bonkers. traipsing all over the world. And even my solar physicist friends, ones who work for NASA, thought I was nuts until, you know, I got a bunch of them together and we all watched it together in Nebraska, and they were like, okay, now I understand why you do what you do, because they could then appreciate the moment with me. And I think so that was a bit of a special one for me. Other ones like the one in Indonesia where I got to see a naked eye prominence for the first time, that was a bit special. In Argentina, I got to see the shadow bands, which I'd heard about for so long but never got to witness. We finally witnessed shadow bands prior to the Argentina eclipse. But yeah, everyone's different, and it's I use it as an excuse to travel. I never would have been to Indonesia or Argentina or anywhere. Siberia, I did the Trans-Siberian Railway to see one in Novosibirsk in Siberia. So I just wouldn't have got to have these experiences if it weren't for eclipse chasing. And the idea was actually given to me by one of my lecturers here, Don Polacco, when he was taught me when I was an undergraduate, and he would take his family around the world whenever there was a solar eclipse. And I went, that's a great idea. I'm going to do that. And I'm still doing it.
All right, thanks. So any other questions? Again, type them in the chat. Or if not, then, well, thank you very much, Ryan.
Pleasure.
So everyone else, thanks for joining. We'll good luck with watching it safely next week. Let's hope for clear weather.
Yep.
And if you know people that missed this, we'll be posting this somewhere, the recording of this, so you can watch it back later on as well. So thank you all for attending, and hopefully we have good weather next week.
Thank you, folks. Cheers.